Hi everyone. In today's challenge, we are going to solve this problem. The problem name is number of increasing path in a grid, and the problem number is 2328. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem, and after that, we are going to move to the implementation part. We are going to implement our logic in Python programming language and not in C++ and Java. Just the reason is that it is a hard level problem, so it's going to take a little time for implementation in C++ and Java as well. So if I started implementing C++ and Java, then the video is going to take more than 30 minutes, right? And so, but I believe guys, if you understood the logic part and if you have seen the implementation in Python, then you can easily implement in your programming language as well in C++, Java, or any other you use like a Ruby or JavaScript. Whatever programming language you use, you can easily implement if you know the logic and implementation of Python, right? So guys, now let's see what this problem says, right? So problem says you are given a m plus n integer matrix grid. So the one thing is given that one thing is clear that what is given a matrix and the size is going to be m cross n. This means this is not a square matrix where you can move from a cell to any adjacent cell in all four directions. So guys, if this is a matrix, right? So four directions is nothing but what? For a cell you can move up, right, left and down. These are the four directions where you can move, right? Return the number of strictly increasing path in the gates such that you can start from any cell and end at any cell. So what we have to do now, we have to return a number of such paths. That means we can start from any cell. It doesn't mean that you are going to start from initially 0 0. No, you can start from 0 1 0 2 any cell, but you have to choose the next cell which should be the greater than the previous one. Means it should be strictly increasing. If you are still not getting what is this meaning, don't worry, we are going to see with example. But for now, just keep in mind that we can't move to that cell from current cell if that cell is not we can say bigger than the current cell. So let's make it clear only here only, because otherwise it's going to make a confusion in the future. So guys, let's say this is the things 2 3 5 4 6 1 0 2 and 4, right? So guys, if I'm here at 5, so where I can move, I can't move anywhere, right? Why? Because if I start to move to the right side, then I have a less number. I should be have the greater number because it says that it's strictly increasing, right? I can't move top, I can't move left, I can't move down as well, right? But if I'm at here too, so I can move top as well because it is 4. It is strictly increasing, right? I can move to left as well. It is 5, right? I can't move down. I can't move right? But I can move in two directions, left and top. So this is what they said. We have to keep moving until and unless we are getting increasing number, right? And we have to return that number paths, right? So how we are going to return? We are going to see that also. Don't worry. In the next line they say since the answer may be very large, return it modulo 10 raised to 9 plus 7. So there may be more than 10 raised to 9, or we can say 10 raised to 9 plus 7 number of paths exist in our grid. There may be, maybe. So if it is so, then we have to return the modulus of this, right? Okay. Now two paths are considered different if they don't have the same number of exactly the same sequence of visitors. So we are going to see this thing how they are going to consider different, how they are going to consider the same, right? So let's see with example one here first of all. So we are given this 1 1 3 and 4, right? So guys, if I start from 1 and stop it there, so this is also what itself a path, right? And this is also itself a path, this is also itself a path. So we can say there are four paths, isn't it? Which is valid, right? Four path is valid, which is in a strictly increasing order because there is only one number. So it itself part are strictly increasing, right? Now let's see what are the paths which exist more than we can say one sequence, right? So now from one, where we can move, we can't move to right side because it is same. It is not in strictly increasing. So from one we can move to three, isn't it? From one we can move to three. So it is going to be one more path which we can say like this. From one we can move to three. Is that make sense? But from one we can move also to four, right? So there is one more path with the two length is four. We can also move from three to four, right? So there is also one path from 3 to 4 because it is also increasing, right? So we can say from for two length we have a three path. So we are going to say earlier there was four path with a one length. Now three paths with the two length. Now let's see for how many paths for three length. So from one we can move to no one, but from one we can move to three. From three we can move to four, right? So there is also one path. That means from one we can move to three. From three we can move to four. So we can say there is only one path exit with the length three. So we are going to say only one. So total, if you will sum up, you are going to get 8, right? So here's the answer also, you can see 8. So I hope now guys you understood that what we have to do. We have to just find the paths which are same. See guys, we can't take this path again, right? We can't take 1 3 4 again because it is going to be considered as same path. It should be either like this 1 Here, if it is here was 3 cell, it should be like this, right? Phase 2. But it should not be take the same number of, we can say, cell again and again. If you have taken this path, then you can't take again in the future. You can take if there is one more number, either lying it to ahead or either lying it to below, right? But you can't take same path again and again. So that was the meaning of two path considered different if they don't have exactly same sequence of cell. If it is like 1 3 5, then it is considered as a different. But if it is again 1 3 4 with this cell only, then it is considered to be a, we can say, false, right? It is not a different. So this was the basically meaning of this problem. I hope guys you understood the problem first of all. Now we are going to see the logic part, but you must be have a clear idea about the problem, right? So if you have understood the problem, let's see logic part, how we can do this thing. Do we need to really find this path with a one length, two length, or three length, or there is another logic? So let's move to the logic part, right? So what I'm going to do is I'm going to just remove this thing first of all, or let me write here logic part, right? Now guys, what I'm going to do, I'm going to say first of all, just for one, you can see that, right? Each cell is going to itself consider as a strictly increasing. So first of all, total path is going to be nothing but, let's say, total path, or we can say result. I personally use the result variable to return something. Result is going to be nothing but n cross m. This must be the answer, right? It should never be the less than this, because each cell must be itself is in a strictly increasing order. So this is the way you can say total path. N cross m considered. Here you can see n was 2, m was 2, so total is 4. So 4 must be there, right? It can be more than 4, but 4 must be there. So we can say result is n cross m initially. After that, what you have to do? You have to start from each cell. I am starting from 0, 0, 0 here. And what I'll do that you can just keep trying from in 4 direction. If you are seeing right, not possible, don't worry. Move to the top also out of bound, don't worry. Move to the left also out of bound, don't worry. Move to the down, yes. Down is, we are having a number which is greater than the current, right? 3 is greater than the 1. Okay, move ahead. Before moving ahead, add into your result. So result, you are going to add 1 plus. Now you are at here, you have taken this path. Now see, is there any more path exist with this? We are going to move to the left side. Okay, we can see out of bound, no, we can't go. Bottom, we can't go. Top, we have already come from there, so it will always be considered as a negative, right? We don't need to maintain a visit set, because if you will see, we can not go to top, because 3, if we start moving to the top, we can say 1 is less than 3, right? We can't go to top, but we can go to right, because it is greater. So we can say, okay, we got one more path, so add one more into this. Okay, now we are at here. Now see, here we can go anywhere. We can't go to left, we can't go to down, we can't go to right, we can't go to up as well, because it is smaller, right? So if it is smaller, so we can't go to anywhere, so we are going to return 0, 1 plus 0. So we can see from 1, not from 1, from 0 comma 0, we are getting a total 2 path. It is a very important you to understand here, right? If you seeing my video and if you feeling like it is really fast, so you can put into 0.75x or 0.5x, but you need to understand this particular thing. 1 plus 1 plus 0 we are getting from this particular 1, or we can say 0 comma 0 cell. That means from 0 comma 0 cell we are getting actually 2 path, right? So we are going to add into result plus equal to 1 plus 1, right? Now let's move to the this one, 0 comma 1 cell. Here if you will see, we can come to this, right? So it is going to be 1 plus, from 4 we cannot go to 3, we cannot go to anywhere, so it's going to return 0. So from 0 comma 1 we are getting only one path, right? Result plus equal to 1 plus 0, right? Now let's move to the 1 comma 0. 1 comma 0 we can move to anywhere, yes, we can move to the right side only. So if we will go to right side, then you can see we are going to add 1 plus, we can't move to top, here anywhere, so we are going to return nothing but 0. So result plus equal to this 4 0 1 comma 0 cell, right? Now we are going to come to 1 comma 1. Here you can see we can't move to any direction, right? So we are going to return nothing but 0. So if you will sum up all these things, see guys, earlier it was n cross m. N cross m was 2 multiplied 2, right? It was 4, right? So here was result 4. Here 4 plus 2 is nothing but 6. 6 plus 1 is nothing but 7. 7 plus 1 is nothing but 8. 8 plus 0 is nothing but 8. So we are going to return nothing but 8 answer, right? I hope it makes sense, right? It is an easy. So it was we can say simple logic, right? See guys, if you understood the logic part, now I will suggest you just go to your programming language. Either it could be C++, JavaScript, Java, Python, Ruby. Go to your programming language, start implementing this. If you understood the logic part, if you didn't, then try to understand it again, or write in the comment section, I did not get this particular point. We'll discuss it in the comment section as well, right? So now I hope you understood the logic part. Let's move to the Python implementation and let's implement it over there, right? So guys, I'm with the Python first of all. Not first of all, it is only the Python language for this video. So what I'm going to do first of all, I'm going to say define function sol, and before that let's calculate n cross m, which is nothing but length of grid and length of grid of 0. N is nothing but tell us that how many rows, m is tell us that how many columns. Once this is clear, we are going to say okay, we are going to make a result variable which is initially going to be n cross m. Fine, and we are going to have one more variable that is mode, which is going to be 10 raised to the 9 plus 7. What I have done, I don't know. Right. Once this is also done, see guys, we are done this thing. So let me make a space clear. See, once this is done, we are going to say okay, traverse over this for I in range of n, for j in range of m, and here you can say if, not if, you don't need to do anything else. Just say result plus equal to. We can say count, not count. We can say solve function. We are going to make a function solve, and then we are going to pass I and j, right? And after that, we can say at the end, we can say return result mode, our mode, right? Because it could be greater than this, so we have to do the mode of this, right? In Python we don't need to do every time, because in Python we can accept a large number of number as well, right? So once this is done, we are going to make a function which is nothing but define sol, right? So let's create a nested function only, define sol, and here we're going to take a row and column, right? And here we can say for first of all, like the directions, it can go to 4 direction, right? So we can say 0 comma 1, this is one direction, and tell me what is this 0 comma 1, is this left, right, or top or bottom? Just tell me. Yes, it is going to be right. And after that 0 comma minus 1, which is going to be considered as a left, then 1 comma 0, which is considered as a bottom, and minus 1 comma 0, which is considered as a top, right? You must know this thing, right? So once we go to all the directions, means 4 directions, we are going to say traverse over each direction for a comma b, for a comma b in directions. Let's give any variable. Our current row is going to be nothing but equal to row plus a, right? So we can say current row and current column. Current row is going to be nothing but row plus a, and current column is going to be nothing but column plus b. Right. So now we are going to check first of all, it is auto bound or not, right? So current row should be greater than equal to 0, right? And current column is also should be greater than equal to 0, and current row should be less than n, and current column should be less than m. And one more thing which we have to check is that it should be have a greater than the current one, right? So this current row, current column should be greater number, right? So we can say great of current row, current column should be greater than, strictly greater than grid of current means we can say row and column, and here I have to make grid, right? So if it is the case, then only you come to this particular condition, and you can say fine, we got one more thing, so we're going to add into our result, right? So we can make a one function, or we can say variable answer, which initially a 0, and here we can say answer plus equal to 1 plus sol, this current row and current column. After that we can simply return our current we can say answer, right? So let's try to run this code and see whether it's working fine or not. It will not work for large test cases currently, but it should pass the, we can sample test case, right? So you can see that it could pass all the test case. But see guys, it will gonna give a TLE, because the you can see the length. If you must always see this constraint, right? Every time you must see. So here we can see constraint in the 10 raised to 5. M cross n should be less than or equal to 10 raised to 5. So it will gonna give a TLE. So what we can do, we can use a we can say memoization. So we can say dictionary. Initially it is empty, we are going to pass it as a dictionary. See, once we are done this, we are going to, before returning the answer, we can say store in our dictionary. So current row, current column should be equal to this dictionary, right? After that, once we are done this thing, we are going to check it here. If this row and column is already explored, means if it is in our dictionary, then we can say return our dictionary of current row and current column, right? Let's run this code. Current row and current column is not coming here, it here is going to come row and column, right? So here we got a wrong answer. See what's happening here. Okay, so we are getting answer 7, but we need answer 8, right? So we have done something wrong over here as well. So let's check it what we have done. Okay, answer we are returning current row, current column is there, and row is there. Okay, so we are mapping with current row and current column, but we need to map with row and column, right? Let's run this code, and I hope guys it will get submitted, right? So you can see both the test case passed. Now let's try to submit this code as well, and we believe it should get submitted, right? So let's see. It's taking a time. Here you guys can see that, right? It's successfully got submitted. So we have successfully implemented with Python, and you can easily implement it in Java, C++, any other programming language as well. If you're facing a difficulty in your programming language, then you can simply write in the comment section. We will try to figure out that as well, right? So that's all guys. In this video we have seen problem understanding part, logic part, implementation part. If you have any kind of doubt in their section as well, you can write it in the comment section. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.